Non-metallic, or NM, cable can be used in a two-story dwelling with a walkout basement. NM cable is commonly used for residential wiring. It is a flexible cable comprised of insulated conductors enclosed in a plastic jacket. NM cable is suitable for branch circuits. Branch circuits extend from the electrical panel to outlets and fixtures throughout the house. Service entrance rating, or SER, aluminum cable can be used to feed the dwelling panel from the multimeter base, which includes the main breaker. SER cable is designed for service entrance conductors. These conductors connect the utility transformer to the electrical panel. SER cable is made of either copper or aluminum. Aluminum SER cable is more cost-effective than copper SER cable. However, aluminum is more prone to corrosion. When installing NM or SER cable, adherence to manufacturer instructions and electrical codes is essential. Some critical considerations include proper support for NM cable. NM cable must be supported with staples or straps at intervals of no more than 4 feet. SER cable requires adequate protection. SER cable must be protected from physical damage, such as by using conduit. All electrical work should be carried out by a qualified electrician. This is particularly crucial for service entrance wiring. Safety is paramount. Building codes typically specify requirements for electrical installations to ensure safety and prevent hazards. These codes often reference the National Electrical Code, or NEC, which is a widely adopted standard in the United States. The NEC provides detailed guidelines for electrical wiring, overcurrent protection, grounding, and other aspects of electrical systems. Compliance with these codes is essential for ensuring the safe and reliable operation of electrical systems in residential and commercial buildings. When selecting NM cable, it is important to choose the appropriate size and type for the intended application. Factors to consider include the ampacity of the conductors, the voltage rating of the cable, and the environmental conditions in which the cable will be installed. NM cable is available in various sizes and configurations such as 14-2, 12-2, and 10-3, where the first number indicates the gauge of the conductors and the second number indicates the number of current carrying conductors in the cable. The ampacity of the conductors must be sufficient to handle the expected load, and the voltage rating must be compatible with the voltage of the electrical system. In addition to NM cable, other types of cables and wiring methods may be used for residential wiring depending on the specific requirements of the installation. For example, armored cable or AC cable may be used in areas where the cable is exposed to physical damage, and conduit may be used to protect conductors in wet or corrosive environments. The choice of wiring methods should be based on a careful assessment of the installation conditions and the applicable electrical codes. When installing SER cable, it is important to follow the manufacturer's instructions and the applicable electrical codes to ensure a safe and reliable connection. SER cable is typically terminated at the service entrance equipment, such as the main breaker panel, using appropriate connectors and fittings. The conductors must be properly sized to handle the expected load, and the connections must be made securely to prevent overheating and arcing. It is also important to ground the SER cable properly to provide a path for fault current in the event of a short circuit. Grounding helps to protect people and equipment from electrical shock and fire hazards. Aluminum SER cable requires special consideration due to the potential for corrosion. Aluminum forms an oxide layer on its surface when exposed to air, which can increase the resistance of electrical connections. To prevent corrosion, aluminum conductors should be cleaned and treated with an antioxidant compound before making connections. The connectors and fittings used with aluminum conductors should also be specifically designed for use with aluminum to ensure a reliable and corrosion-resistant connection. Regular inspection and maintenance of electrical systems are essential for identifying and addressing potential problems before they become serious hazards. Electrical panels, wiring, and connections should be inspected periodically for signs of damage, overheating, or corrosion. Any loose or damaged component should be repaired or replaced promptly. It is also important to test ground fault circuit interrupters, or GFCIs, and arc fault circuit interrupters, or RFCIs, regularly to ensure that they are functioning properly. GFCIs and FCIs are designed to protect people and equipment from electrical shock and fire hazards, and they should be tested monthly according to the manufacturer's instructions. When working with electrical systems, it is important to take appropriate safety precautions to prevent electrical shock and other hazards. Always disconnect power to the circuit before working on any electrical components. Use insulated tools and wear appropriate personal protective equipment, or PPE, such as safety glasses and gloves. If you are not comfortable working with electrical systems, it is best to hire a qualified electrician to perform the work. Only qualified electricians should work on the service entrance, which is the connection point to the utility. The service entrance typically includes the meter and main breaker. Working on a live electrical service is extremely dangerous and should only be performed by qualified professionals with the proper training and equipment. If you notice any signs of electrical problems, such as flickering lights, burning smells, or tripped circuit breakers, it is important to investigate the problem and take corrective action promptly. Ignoring electrical problems can lead to serious consequences, such as electrical shock, fire, and equipment damage. If you are not sure how to address an electrical problem, it is best to consult with a qualified electrician. Electrical codes and standards are constantly evolving to reflect new technologies and safety concerns. It is important to stay up to date on the latest requirements to ensure that electrical installations are safe and compliant. Electricians and other electrical professionals should participate in continuing education and training to maintain their knowledge and skills. Homeowners can also benefit from learning about basic electrical safety and maintenance practices. This knowledge can help them identify potential problems and take steps to prevent accidents. Ultimately, ensuring electrical safety requires a collaborative effort between homeowners, electrical professionals, and regulatory agencies. By working together, we can create safer homes and communities. Proper grounding is a critical aspect of electrical safety. The grounding system provides a low impedance path for fault current to flow back to the source, allowing overcurrent protection devices, such as circuit breakers and fuses, to trip and energize the circuit in the event of a fault. A properly grounded electrical system helps to protect people and equipment from electrical shock and fire hazards. The grounding system typically consists of a grounding electrode, such as a ground rod or a metal water pipe, connected to the electrical panel with a grounding conductor. The grounding conductor is also connected to the metal enclosures of electrical equipment, such as appliances and lighting fixtures. This ensures that the metal enclosures are at the same potential as ground, reducing the risk of electrical shock. Ground fault circuit interrupters, or GFCIs, are another important safety device that can help to prevent electrical shock. GFCIs are designed to detect small imbalances in current between the hot and neutral conductors in a circuit. If an imbalance is detected, the GFCI will trip and energize the circuit quickly, preventing electrical shock. GFCIs are typically required in wet locations such as bathrooms, kitchens, and outdoor areas. Arc fault circuit interrupters, or FCIs, are designed to protect against arc faults, which are a common cause of electrical fires. Arc faults occur when electricity jumps between two conductors, creating a high-temperature arc. FCIs detect the characteristics of arc faults and trip the circuit breaker to de-energize the circuit, preventing a fire. FCIs are typically required in bedrooms and other areas where people may be sleeping. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect electrical circuits from overloads and short circuits. Overloads occur when too much current is flowing through a circuit, causing the conductors to overheat. Short circuits occur when there is a direct connection between two conductors, causing a large amount of current to flow. Circuit breakers and fuses are designed to trip or blow when the current exceeds the rated ampacity of the circuit, preventing damage to the wiring and equipment. It is important to use the correct size circuit breaker or fuse for each circuit. Using a circuit breaker or fuse that is too large can allow too much current to flow, which can cause the wiring to overheat and start a fire. It is also important to replace circuit breakers and fuses that have tripped or blown. If a circuit breaker trips or a fuse blows repeatedly, it is a sign that there is a problem with the circuit that needs to be investigated. Electrical wiring should be installed in accordance with the applicable electrical codes and standards. These codes and standards specify requirements for the size and type of conductors, the methods of installation, and the protection of wiring systems. Following these requirements helps to ensure that electrical wiring is safe and reliable. Electrical wiring should be protected from physical damage. Wiring that is exposed to physical damage should be protected by conduit or other means. Conduit is a rigid or flexible tubing that is used to enclose and protect electrical wiring. Conduit is available in various materials, such as metal and plastic. The type of conduit used depends on the application and the environment. Electrical boxes are used to enclose and protect electrical connections. Electrical boxes are available in various sizes and shapes. The size of the electrical box depends on the number and size of the conductors that will be enclosed in the box. Electrical boxes should be properly grounded to provide a path for fault current in the event of a short circuit. Electrical connectors are used to connect conductors together. Electrical connectors should be properly sized and installed to ensure a secure and reliable connection. Electrical tape is used to insulate electrical connections. Electrical tape should be wrapped tightly around the connection to provide a waterproof and airtight seal. Electrical safety is everyone's responsibility. By following basic electrical safety practices, we can help to prevent electrical shock, fire, and other hazards. If you are not comfortable working with electrical systems, it is best to hire a qualified electrician to perform the work. A qualified electrician has the training and experience to safely and properly install and repair electrical systems. Firstly, always disconnect power before working on electrical circuits. Secondly, use insulated tools and wear rubber gloves. Thirdly, never work on wet surfaces. Fourthly, inspect wiring for damage before working on it. Fifthly, test circuits with a voltage tester before touching them. Sixthly, label circuit breakers clearly. Seventhly, replace damaged outlets and switches. Eighthly, keep electrical panels clear of obstructions. Ninthly, don't overload circuits. Tenthly, install ground fault circuit interrupters or GFCIs in wet areas. The National Electrical Code, or NEC, Table 310.15b16 provides ampacity ratings for conductors. These ratings are based on the conductor size, insulation type, and ambient temperature. The ampacity of a conductor is the maximum amount of current that it can safely carry without overheating. It is important to select conductors with an ampacity that is sufficient to handle the expected load. The NEC also specifies requirements for the minimum size of conductors for various applications. These requirements are based on the load that the circuit will be carrying and the length of the circuit. The longer the circuit, the larger the conductors need to be to prevent voltage drop. Voltage drop is the reduction in voltage along a circuit due to the resistance of the conductors. Excessive voltage drop can cause equipment to malfunction or operate inefficiently. The NEC provides guidelines for calculating voltage drop and for selecting conductors that are large enough to minimize voltage drop. The NEC also specifies requirements for the grounding of electrical systems. Grounding is the process of connecting electrical equipment to the earth to provide a path for fault current in the event of a short circuit. A properly grounded electrical system helps to protect people and equipment from electrical shock and fire hazards. The NEC requires that all metal enclosures of electrical equipment be grounded. This includes electrical panels, junction boxes, and equipment housings. The NEC also requires that the grounding electrode be connected to the neutral conductor at the service entrance. This creates a low impedance path for fault current to flow back to the source. The NEC also specifies requirements for the overcurrent protection of electrical circuits. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect electrical circuits from overloads and short circuits. The NEC requires that all electrical circuits be protected by overcurrent protection devices. The size of the overcurrent protection device must be appropriate for the size of the conductors and the load that the circuit will be carrying. The NEC also specifies requirements for the installation of electrical equipment in hazardous locations. Hazardous locations are areas where there is a risk of explosion or fire due to the presence of flammable gases, vapors, or dusts. The NEC requires that electrical equipment installed in hazardous locations be specially designed and approved for use in those locations. The NEC also specifies requirements for the wiring methods that can be used in hazardous locations. These requirements are designed to prevent ignition of flammable materials in the event of an electrical fault. The NEC is a complex and comprehensive document. It is important to consult the NEC and other applicable codes and standards when designing and installing electrical systems. A qualified electrician can help to ensure that electrical systems are installed safely and in compliance with all applicable requirements.